Hello everyone, welcome back to the class. And before going to the further concepts of your chapter, that is electric charges and fields, we will be having a small recap of what all we studied in the last class. And it was about electric flux, where electric flux tells you about electric field lines itself, but another concept comes into picture, that is your surface. So it is nothing but a total number of field passing through a surface normally, so it is perpendicularly, that's it. And you have got your SI units also, you have to keep it in your mind and you have to remember it. Next, going to another concept, yes, this is nothing but the electric flux itself, but in case 1 and case 2. And why do I take it as case 1 and case 2? It is because I have got one trigonometric function, it is cos theta. And why only cos theta we are going to use, and this is what the proof we had learned in the last video, last class. So next, going further, this is how we are going to give a formula for the electric flux, that is phi is equals to E into delta. Yes, as I told you through the definition, it is your electric field lines passing through a surface. So delta tells you about small surface, so delta, yes, it is small surface. And you have got one component, that is your trigonometric component, and that is cos theta. And why cos theta, you can go to the previous video, you can check over it, why only cos theta we use and why not sin theta. So next, going to the next concept, that is something called as the electric dipole. So electric dipole, why do we actually learn this concept? Because it is useful in terms of derivations. When we derive certain derivations, it is very much useful for us to consider two charges, equally distribution of charges, and unlike charges also, which is divided by certain small amount of distance, that is 2a. And you will be learning about this dipole in terms of uniform charges. So whenever you have got uniform electric fields and the charges, they are equal to one another, and you can find that the charges over them are zero, that is neutralized. So positive charge and a negative charge you have got, and this is something called as electric dipole, which is a very important concept. You'll be learning this not only in this chapter, in coming further chapters of your second PUC also, and this is your basic which you have to learn. So if you want to learn more and more of what is electric dipole, you can go to your chemistry subject, and in that it is given in depth, so you can learn over there. And here, why do we use this electric dipole as it is a small concept where we require to derive some derivations, that's it. So only thing you should learn with what is electric dipole, it is a system of two equal and unlike charges separated by a distance. Next, going to give the expression of what is dipole moment. So it is same, electric dipole means dipole moment. It is denoted by a capital P with a vector symbol, and it is equal to product of charge and the distance. So we can consider only one charge and the distance, and the distance is given by 2a. So this is your SI unit of dipole, that is your coulomb meter. So as your formula is charge into distance, yes, for charge it is coulomb and your distance is meter. So this is your vector quantity, it gives you the direction, and its direction is always from your negative charge to the positive charge. Next, we also studied about how we are going to find out the electric field due to a dipole, but what is the condition given on the axis. So if I consider this is the axis where your dipoles are there, and on the axis, yes, the straight line, at some point P, you're going to find the total electric field of these two charges. So this is what we studied in the last class. So in this class, this video will be studying about another concept, that is your derivation, which tells you about finding electric field for points on the equatorial line. So if I consider this is your dipole at some point on the equatorial. So what is that equatorial? It's something tells you about, it's a perpendicular distance from the midpoint of the dipole. So this is your dipole and this is the midpoint, and perpendicular to it you have got a point where you will be considering that as your equatorial point, where it is something called as P. The point is P. You're going to find the total electric field of a dipole, not on the axis but on the equatorial line you'll be finding. So firstly what we have to do is we have to, so what is the actually what is the aim of this derivation is to find the electric fields at point P. So how we are going to find it is individually. So what kind of individuality you're going to find out is, if I consider the negative charge, this charge produces the electric field, and positive charge produces an electric field, and you're summing up these two, and how you're going to sum up is very much important in this derivation. So they have given you that electric field at P due to plus charge, that is positive, and a negative charge. So now what is that you have to understand? First, a pictorial representation, let me explain it to you, and then you would understand further derivations of this concept. So now if I consider a dipole, yes, you have got a dipole which is unlike charges positive negative, and at midpoint you have a center where the distance of it is measured. So if I consider the midpoint to one charge, the distance is A, and midpoint to another charge, the distance is A. So the total charge of this is 2A. Now if I consider this point, and this point tells you at where you have to measure or calculate the electric field. Now if I consider the positive charge, yes, if I consider the electric field lines of a positive charge, what happens? It is radiated outward. So you can see the arrow mark, it's been outward. So which is passing through this point P, and it is radiated outward. So now if I consider this negative charge, so as I have told you from the properties of the electric field lines, the line that is your electric field is originating from your positive and terminating towards your negative charge. And yes, you can see that your electric field, so if you just observe the picture, you can see that your electric field is directed inward. So yes, now you can see that it is originated and it is terminating at your negative charge. Now what do I do? You have got one electric field E1 of charge Q, positive Q, and electric field E2 of charge minus Q. So now if I consider the first E1 electric field, so this has been split up into two components. So how two components it's been split up? It is at this point you can see it is E1 sine theta. How do you find it is only sine theta over here? And why not here? If I consider this triangle, I take angles over here from the distance of the dipole to the electric field. I would consider only one angle at which point? A or else B. Now if I consider this would be the angle of the triangle, the opposite side is opposite according to the trigonometric function. So opposite is something that's sine theta. So if I drag it furthermore, you can find that it is sine theta at this point, at this line. So now vertical line, I mean to say. Now if I consider the horizontal one where it is being split up, which is the electric field is split up, E1 is split up into two components. So E1 is sine theta. So E1 of the horizontal plane is something called as cos theta. So I can just write it E1 cos theta. Now coming further, if I just considered E1 electric field. Now if I consider E2 electric field, so E2 field is in this way. So as this is another electric field, this also would be split up into two components. So electric field, that is E2, is split up into two components. Which way? As I'm showing you, it is in downward and again onto the horizontal side, and this horizontal side tells you again it is a cos theta. And what about the vertical line? It tells you about sine theta. The component is sine theta as it is vertical. As I told you, this angle opposite to this is sine theta according to your trigonometric functions. So now you have got at this point, or at your horizontal point, you have got E1 cos theta plus E2 cos theta. So which is it? This is the resultant R, as you can see. Now if I consider these two, E1 and E2 of a component sine theta cancels each other. Why does it cancel each other? They are in the opposite direction. Now if I consider this resultant, the entire electric fields of the dipole is concentrated on which component? So if I say, it would be concentrating on the cos theta, the component, trigonometric component of cos theta, and the total resultant of the electric field would be, as you can see here, just concentrate, it is the total electric field is concentrated on E1 cos theta plus E2 cos theta. So I hope I have made it very clear to you. So only thing, when this is of your PPT presentation, you have to just concentrate on my words, and you have to imagine, as this is your physics subject, you have to imagine certain things, and only then you'll be perfect with the concepts. So now if I consider, as we studied the pictorial representation of this derivation, let me go with deriving with certain equations using this pictorial representation. Now if I consider individual charges of the dipole, so E positive charge I would take, so that is a charge which produces a electric field. So E is equals to, what is the exact formula of electric field? It is 1 divided by 4 pi epsilon naught q divided by r square it was. So now if I consider the distance, so what is the distance now? I cannot just write r square, is it? So now if I consider the distance is given by r square. So what is the distance first of all? So from the charge to point P, I can just take by the Pythagoras theorem, the two sides I'm going to square and add it. So r square plus a square. So this distances of the triangle is a, okay. So a square plus r square is equals to the hypotenuse, what you get, square of the hypotenuse. So what do? I take it onto my right hand side, and what do I get? R square plus a square, I told you. But what about the root square of the hypotenuse? I take it to my left hand side, and I would take it root of r square plus a square. So that root, whatever it was there, I have taken it to the power of half. So root of r square plus a square, that is the formula you would get of this distance. But what do? The root I don't take. Instead of root, I am taking half. So r square plus a square to the power of half. So now, as the formula is E is equals to 1 divided by 4 pi epsilon naught q divided by r square minus a square, is it? So it is the distance is r square plus a square to the power of half. So a small changes I need to tell you, that the distance here, some error, typing mistake, so please do correct it. It is not r square minus a square, but r square plus a square, okay. So q divided by r square plus a square. So actual formula was r square, is it? Now what is the power of this one? 1 divided by 2. So 1 divided by 2 into 2. So 1 you would get. So half into 2. So what happens, this 2 and this 2 is cancelled, and that is why you do not have any powers over here. And again I'm telling you, the distance of this one is r square plus a square. So please make a note of this and do not make any sorts of mistake. So now if I consider the electric fields of the charge minus q, you can see that the distance over here is same as r square plus a square to the power of half. So here also you will be getting the same thing. So what will happen, r square, no, so distance is how much, r square plus a square to the power of half. So half into 2, 2 gets cancelled and the power becomes only 1. You have to concentrate and then only you will understand whatever I'm telling you in this video. So now if I consider the electric fields on both the sides of the charges are same. So now what is the thing we have to do? So we have to find the total electric field at what point on the equatorial point. So now before going that, I would just like to tell you that E is equals to, you're taking two components, which is a electric field of cos theta plus minus charge electric field cos theta. So which component you're taking according to this figure? You can see that it is only cos theta which will remain and sin theta is cancelled away. So now if I consider with this one, E is equals to E cos theta plus E cos theta of two charges. You can see that positive charge and a negative charge. So just put the formula whatever you have calculated, taking cos as common. So in this equation what you're going to do, you're taking cos as common. So going back to the equation, so these are the electric fields of charge q and minus q. So what you're going to do, both are same, no, so what you're going to do is twice of 1 divided by 4 by epsilon naught q divided by r square plus a square. Again I'm telling you, please do correct it. So now if I consider this one, so now what is it, charge electric fields of both the charges you have got, and what is that, you're going to write 1 divided by 4 pi epsilon naught and twice 2 you have written because you're adding these two, and you have taken cos as common, cos theta as common. So 2q divided by r square plus a square into cos theta. P is your direction it gives you. Now understood? So now if I consider E, whatever the two e's you have added, it is again written the same, but for cos theta you have to write the value. So how we are going to write the value of cos theta? So let us go back to the picture. So this is your image where you can find, take any one of the triangle. So take any one of the triangle. In this triangle, for cos theta, so actually what is the formula of cos theta according to your trigonometric functions? It is adjacent divided by hypotenuse. So what is adjacent in this diagram? So in this triangle, which is your adjacent? As I told you, take angles over here because you're finding an angle between your dipole and the electric field, and this is the angle you have to take. So if this is your angle and r, this side would be sine theta according to your trigonometry. So what about the remaining side? And this is your hypotenuse and the remaining side is your adjacent. So what, this would be your adjacent. What is the distance of this one? So from your center to a charge, so that would be a. So your adjacent is a, you have got now. Now if I consider your hypotenuse, the longest side of your triangle, so what is the value of this one? R square plus a square to the power of half. This is according to your Pythagoras theorem. So you got your cos theta. Yes. So now as you have learned how to calculate your cos theta, you take this value, and what you're going to do after taking this value, just put it into this formula. Hope I'm making you very much clear with my explanation. So the same thing, a divided by r square plus a square to the power of half, you take it here, a divided by r square plus a square to the power of half. So what is that you're finding common here is, so one thing before that, 2qa. Have you seen this equation anywhere? That is in your dipole. So P is equals to charge into the distance between the two charges. So yes, so if I consider 2qa, it is telling you about the dipole, and which tells you about the product of a charge and the distance between the dipoles. And how is it going to represent? It is represented by P. So this is one of the thing you have to know in the next equation, next thing whatever you substitute. And then what is common? And in a denominator you can see that r square plus a square is common. But what about the powers? So here you have got half and here you have got 1. So 1 plus half, 3 by 2 you will get. So in this you can see that yes, I have written P, that is your dipole, divided by 4 pi epsilon naught. So into, I have taken your denominator, that is r square plus a square to the power of 3 by 2. So here dipole equation I have written. So in case if I consider the distance of r is very much greater than a, if I consider, say if I consider with this pictorial representation, this distance if it is very much greater than a, so a is vanished. So a is very much small and this is vanished and a square is gone. So now what is remaining? R square into to the power of 3 by 2. So 2 and 2 gets cancelled and finally you would get P divided by 4 pi epsilon naught R cube. So this is your electric field representation or the formula for what? To find the electric field on the equatorial point. Hope I have made you very clear what do you mean by equatorial point and how to derive an electric field keeping a dipole, and at which point? At your equatorial point. And this is how you are supposed to derive an expression for what? Electric field at an equatorial point. So next, going to another concept, that concept is something called as torque. So before going to torque, we should learn what is a dipole in a uniform electric field. So suppose I have got many electric fields. So in this way, the biggest arrow marks in the picture. So in that, if I keep a dipole, okay, so this would be your dipole. What is a dipole? Where you have got unlike charges separated by a small distance. So q and q. So positive q and a negative charge. Q in the sense it is a charge and it is separated by a distance. Which is the distance? It is 2a. They have represented already. So now if I consider the electric field lines, so if I consider at this point and at this point, the two sides of the electric field lines, can anybody guess what charge would be here and what charge would be on this side? So just because this is your electric field lines which is radiating in this manner, that is, if I keep a positive charge, it means that it is the positive charge is radiating electric field outwards. So I can keep a positive charge here. Now if I consider a negative charge over here, so what do you mean by a negative charge? How your electric fields are radiated? It is radiated inwards. So it is terminating towards negative charge. So what is it? I can keep a positive charge here and a negative charge here. Your electric fields are originated from a positive charge and terminating towards your negative charge. So positive to negative. So your electric field lines are in this way. So what is the thing you have to understand here? There is a positive charge and here it is a negative charge. Now if I consider a dipole, so just children just understand, if this dipole is kept very straight vertically without no angles creating except 90 degree towards what? Your electric field. Just you suppose that Your charge q is over here and negative charge is over here. It is very straight. So now according to the positive charge over here onto your left hand side and negative onto your right hand side, just tell me how would your positive charge move towards. So will it move towards your positive charge or else towards your negative charge? Obviously your charge moves towards your negative. So that is why you can see that the direction is in this way. Yes, you're understanding? And now, if I consider the negative charge, now you can tell me where does it go, whether it goes towards the negative or a positive charge. Yes, it goes towards the positive charge because unlike charges attract each other, and that is why you have got a direction in this manner. So hope you have understood that, that is when a dipole is kept in a uniform electric field, it experiences some forces. As these two charges are being concentrated at the center, so it would find a rotating force. So torque is something that it rotates an object. So I can say torque is a rotating force, and you can see that your charge moves towards the what is it, the positive charge move towards your negative, and your negative charge moves towards the positive. And this is your pictorial representation how your dipole behaves in a uniform electric field, and that charge or the force is something called as torque. So how torque is being applied, and here as it is a vertical, it is opposite to this angle. So you're having a charge here minus q and the field lines, and this is making certain angle, and this one I would consider it to be as sine theta, and you can find that the distance of this one is 2a. So what is the distance? 2a. Why? Because the distance of the dipole is 2a, and that is why you're going to write it as the distance is 2a sine theta. So if I consider in this triangle, this is your adjacent and this is something called as 2a cos theta. The value according to the trigonometry is 2a cos theta, and this is your hypotenuse, that is I have just represent that by p, that is your dipole, the distance itself. Now if I consider the charge q, I can say that it is experiencing certain forces, and that force is equal to q into e. What is it? It is F is equals to q into e. So if I consider electric field formula, that is in the slide that you can find that F is equals to E into Q. So if you have got a charge and an electric field, then the charge experiences certain force, and that is how I have written in the diagram, that is F is equals to Q into E. So that charge is experiencing certain force, and that is equal to E into Q. And so this formula, so this is what everything about your torque and the dipole in uniform electric field. So now going to understand the formula of a torque. If I consider a torque, it tells you about the formula, that is force into arm of couple. So arm of couple, instead of this you can also understand that as the distance between the two forces. So if, or the perpendicular distance, so if I consider this is a force, yes, so this is the force and the distance between them is perpendicular to the force 90 degrees. So force into perpendicular distance between the two forces. So this is a force, this is the force, this force is acting on the charges of a dipole. So now if I consider the torque, you can say that what type of force and what is the formula of a force a charge is experiencing. It is q into e. So that is q into e you have got. Yes, you have got here, and the same thing I would write it in the formula into perpendicular distance they are asking for. So if I consider this is the perpendicular distance of the two forces, and what is the perpendicular distance formula? It is 2a sine theta. So 2a sine theta you're going to write. It is so easy. And now what do you find over here? It is 2a, the distance into charge, which tells you about a dipole. Yes, and this formula 2aq is nothing but p. You are going to replace this thing with p into, and what is the remaining thing you would find after taking out 2a into q? It is e and sine theta you would get, and this is the formula of a torque, and it is something called as torque is equals to p e sine theta. So this is all about torque, and in our today's class we studied about how to derive an equation for the electric fields of a dipole at a equatorial point, and also we studied about one more concept that is a very much important concept, that is something called as torque. So hope I have made you very clear with all the concepts. So if you have liked the video, please do subscribe and like the channel, and please support us. Thank you.